So let's get started. Hello, everyone. Welcome to today's Mobility Forum. This is episode 150. It's also the last episode of Spring 2025 Mobility Forum. My name is Jinhua Zhao, Professor of Cities and Transportation at MIT. Today, we'll have a panel discussion on unconventional electrification. In the United States, we replace about 5.4% of vehicles every year. So even in the extreme case where every new vehicle sold today is electric, it takes about 18 to 20 years to complete the transition. While in reality, EV accounts for about 10% of the new vehicle sales and even a potential downward trend this year. So this raises a critical question. Instead of waiting for all the vehicle fleet to turn over, can we retrofit the vast amount of existing internal combustion engine vehicles already on the road? And also, can we do the same thing to convert the bicycles to electrify the truck trailers? To explore those ideas, we're delighted to have Ali Javidan from Range Energy, Sam Ray from CLIP, and Tom Gursky from Blue Dot Motorworks to join us. They'll give us 3 examples of this non-conventional electrification strategy. Bhuvan designed today's panel, and he will introduce the panelists and moderate the discussion today. Before that, I just to reinforce the norm of this forum, which is everyone contribute one idea, either in the form of a comments to the presentation or a question to the panelists. You can write them directly into the chat. Now I'll give the floor to Bhuvan, please.
All right. Thank you, Jinhua. So as Jinhua mentioned in this session, we move away from the regular types of electric mobility modes, e-bikes, electric trucks, electric cars, and delve into these innovative approaches to electrifying existing transportation, featuring products from these 3 companies that in my mind are taking similar approaches to different product categories. First we have Range with the truck trailer electrification. We have CLIP, the nifty regular bike to e-bike conversion, and Blue Dot Motorworks with this hybrid kit retrofit to existing petrol powered cars. So Jinhua touched upon this, but we have like a fleet of 1.5 billion cars on the road globally today. Millions of heavy-duty Class 8 trucks. I think in the US, it's maybe 3 or odd million. Ali, you'll probably have the figure on this. And I don't know, globally, probably 1 billion bikes. Though if you are looking for bike parking at MIT during the academic term, you feel like it's more. And these numbers are increasing. It's not like, these numbers are decreasing because we're still selling a lot of these right now, and more than electrification, right? Electric cars in the US is, 7, 8, 9, 10%. And the replacement rate is very slow, and people usually underestimate this. Once a car is sold in the US, it's on the road for 16.6 years as an average. So you have cars that are on the road for 22 or 23 years. So that's a long amount of time. And so even if every new bike, every new car, every new Class 8 heavy-duty truck sold today is fully electric, it will take decades before our transportation fleets are fully electric. So, and this transition to make everything fully electric has a lot of challenges: materials, cost, time, geopolitics, to name a few. And we've touched upon a lot of these challenges previously in the forum. So, so now that we've set the context, let's explore how these solutions are, helping to address some of these issues. So I'll quickly introduce the panel, and then they will give a quick, 6-minute presentations. Then we can, probably have some good discussion, and then our typical audience Q&A curated by John. So starting with Ali. Ali Javidan is a hands-on engineer with a history of leading pioneering teams at Tesla, Google, and Zoox. As an early hire at Tesla, Ali built the very first Model S and was responsible for early stage testing and development for all vehicle programs. Prior to founding Range Energy, Ali architected the prototyping and experimental operations org XOps at Zoox, supporting the ground-up development of all vehicle platforms at the company. At Google, Ali led the ATAP Skunkworks team, where he filed 15 patents in the areas of micromachining, additive manufacturing, and robotics. And his early career was at Caltrans and as a racing team engineer, and currently served as a venture partner at R7. Good to have you, Ali. So let me quickly introduce Som. Som Ray is a design technologist and entrepreneur with over 20 years of experience building impactful consumer products across hardware and software. Trained as an architect and shaped by his time at Media Lab, Smart Cities Groups, he has led ventures ranging from early EVs in India to award-winning inclusive design. as CEO of CLIP, a Brooklyn-based clean mobility startup. You can see the new lab background behind Som. He's pioneering a patented tool-free e-bike upgrade that makes sustainable urban commuting more accessible and affordable. Thanks, Som. Good to have you here. And lastly, let me introduce Tom. Tom earned a degree in mechanical engineering right here at MIT and set about a career turning out new and impactful technologies into products. He developed Stirling engine generators for the alternative energy sector, medical devices for the detection and treatment of diseases, and mobile latrine processing systems to improve sanitation for those experiencing the world's worst poverty. He founded Carbine Enterprises, an engineering and product development consultancy, serving everything from startups to Fortune 150 companies. His latest venture, Blue Dot Motorworks, will accelerate the decarbonization of road transportation with conversion kits that can help electrify any of the 1.4, 1.5 billion cars that are already on the road. So thanks, Tom. Good to have you here. So we'll just kick in with the presentation soon. So Ali, if you could share your screen and kick us off. 6 minutes, and I will cut you all off if we are getting short of time. Thank you.
All right, we will blaze through this material. Hi, everybody. All right, so I'm Ali Javidan. I'm the founder and CTO here at Range Energy. The idea here is let's electrify all the trailers. Kind of long story short. Essentially, what we've put together is a very basic system that looks pretty simple on the surface, but has quite a bit of sophistication and controls underneath. And I'm diving right into the technology and kind of saving the pitch for other folks here. We're working with world-class, top-level Tier 1 partners for things like e-axles and battery components. We put those systems together into an energy module and into a drive module. The energy module houses, in this case, almost 300 kilowatt hours of stored energy, along with all of the ancillary components. The drive module, again, comes from a world-class Tier 1 supplier, and then that gets dressed with some of our controls components and some of the accessories that the customer chooses. Then that gets bolted into these trailers. And Bhuvan, you said some of the statistics. There are 3.5 million Class 8 trailers on the road today, and there's about a 3-to-1 tractor to trailer ratio. So there are 3.5 million trailers on the road, and about 1 or 1.25 million tractors on the road. And there's about a 10% turnover every single year on these fleets. And these fleets typically keep these assets between 8 and 12 years. So it gives you kind of a sense of use. The usage patterns are a little bit different than consumer products. All of our components are meant to integrate into the existing infrastructure and service infrastructure as well, so that when our kit shows up to the yard, it can be integrated into any of those existing 3.5 million trailers that are on the road. But we can also capture the brand new trailers and then integrate this kit line side. What makes the system work all together the way that it does is our software and our sensing suite that sits on top of all of these kind of, let's say, off-the-shelf components. We are able to infer drive state and understand in real time what the conditions are of the vehicle, and we can provide propulsion assistance in real time with no data connection to the tractor. This allows us to put this system, essentially we're building a large collaborative robot here, and we can put this system behind an old diesel tractor and take it from 6 or 7 miles per gallon up to 12 or 14 miles per gallon or even more. We can also double the range of a brand new electric tractor with this system, and we're doing all of this by sensing the first principles physics. We sense in real time how hard the tractor is pulling on the trailer. Then we combine that with other sensing modalities that we have on our system, and we pull drive state and infer driver intent in real time. So for example, if the driver is driving up a hill and we need to do a little bit of torque fill to help them accelerate up that hill while they have a heavy load, that minimizes the raw unburned fuel that goes into the diesel engine, but that also helps propel that trailer through that intersection or up a hill in a safe way. We can also use this state-of-the-art motor in things like stability control and traction control. So I'll kind of keep going a little bit, talk a little bit about the company. We talked a little bit here. at the end of the day, one piece that I want to kind of extract from this slide is that if this does not make sense financially for this commercial industry, it's not going to work. We can't really sell on emotions here. And so this is one of the first pieces of decarbonization technology that we've developed completely focused on the ROI, the payback period, in addition to all of the other benefits that we provide as a baseline. Ultimately, we have an opportunity here to build the safest trailer system that has ever existed. And what I'll show you here is a quick 1-minute video about how we can perform, in many cases, multiple times better than baseline ABS, using our trailer e-axle and our sensing system in an intelligent way to control that trailer. You have to remember, on the road, these tractors weigh, let's say, 18,000 pounds. The trailers can weigh as much as 65,000 pounds. And that trailer has no controls other than baseline hydraulic ABS, which is very, very high latency and very low control. And so what you end up having is this big box that tries to control the kinematic system, and you're trying to control it all with this little tiny tractor sitting in the front. We flip the equation here.
I'm Ryan Flatland, head of simulation and controls here at Range. We're out testing for the first time on snow and ice conditions with our Range trailer. The exciting part is how we can not only save fuel, but also help improve safety and stability. What we're happy to see is we're actually improving in almost every condition that we look at, making it easier for the driver to control.
So ultimately, we want to make the roads safer. We want to make them more efficient. And if you see, we're not just throwing technology at this product. We're really, really trying to make sure that this connects to the end user. And this is something that I learned early in the days at Tesla. And as you may have heard, I ran the vehicle prototyping team at Tesla. That is the first ever Model S Alpha #1. That was about 3 in the morning after multiple weeks of sleepless nights. But this was when we knew that it didn't really matter what was under the skin and how much technology we can shove under the skin of this car. What really ultimately mattered in that moment was the experience that we were going to bring to the world. The electrified experience really changed so many different things. And from that moment on, I focused my career on improving the user experience, not just throwing technology at things. And that's what we're doing here. As you can see on the left, that's our first test trailer. And we're shipping trailers starting at the end of this year, and we're always focused on that user experience. And the last video I'll show you is the customers using our trailer and what that benefit is to them.
Range's e-trailer is a trailer that propels as well as electrifies the reefer, which is a huge asset for us, saving fuel mileage for the reefer as well as fuel mileage for the tractor. I-80 and 50 here are summits that we have going into the Nevada state line. Those elevations are fairly steep. If you're fully loaded going up the hill, it definitely takes a toll on the equipment, on the tractors, and a lot of stress on the motors. We have an average around 8.1 miles per gallon, and we were seeing up to 14.5 on some of the routes that we were running. Range's e-trailer really helps our electric e-Cascadia by extending its range. So we've gone further than we have gone before. Getting it to real customers, making real deliveries, it's huge.
When I was first asked to run the route with the e-Cascadia and the Range trailer, honestly, I was very nervous because the route itself was beyond capabilities of the tractor. Even throughout the day, I was kind of nervous until we started getting close to being home and we realized we had a lot of power to spare. We were told the range of the tractor itself was 200 miles. With the Range trailer, we were able to go 224 miles and still come back with 41% battery.
I've been driving for 35 years in all kinds of different trucks and trailers. And in my whole history of driving, I've never seen anything like this that could put the kind of power that it did and increase the fuel mileage like it did. And what I really loved about it is the braking. When you're going down an incline, when you hit the brakes, it aids you in the braking going downhill, so you're not hitting your brakes all the time. And another benefit of it too was the quietness of it, because we do go into a lot of areas where we're in residentials, and it really helps to not have a really loud diesel engine running the reefer units and waking people up.
A commercial truck with a large payload, usually even on acceleration, even in automatic, there's a lag time in throttle, sometimes 2 to 3 seconds. With the e-trailer, we didn't notice that. It was like almost instant power. You're taking off quicker and getting up to speed faster. I was probably, route-wide, it was probably like 20, 30 minutes faster drive time. It was basically like driving a sports car, it felt like, compared to a normal truck.
We've used many different EV trailers in the past, and there's always some little nuance to it that causes some extra training or extra guidance. This one was very simple to use. It's a fresh breath of air, just having an electrified vehicle that comes on board, and it's just like every regular trailer out there.
Thank you guys so much.
Thanks, Ali. So, can we move on to you next? Thank you.
Sorry, I think I where is it?
Yep, we see your screen.
All good?
Yeah.
Hey everyone, I am Som. I am one of the co-founders and CEO of a company called CLIP. We're based out of Brooklyn, and I want to kind of, I'll keep this short, and I want to kind of set the premise for how we are sort of looking at this sort of niche to decarbonize sort of transport emissions. The niche we are looking at is the 3 to 15 mile commute. We all kind of know this, 20-25% of all global emissions are from the transportation sector. 40% of that transportation sector are from the passenger commutes. And then a slice of that, the 25% of these commutes are from the 3 to 15 mile commutes. This is kind of interesting for us because I think this is where we can, have a really sort of positive impact in getting people, if we can help people to kind of switch over from the regular sort of modalities that they currently use. Now, if you also look at, how we are going to do that, and if you look at the globally, the countries that are responsible for these commute emissions, 70% of these are just the 10 countries. And out of the 10 countries, the 5 of them are 70% of that chunk, which if you remove India, which is the only sort of emerging economy out of them, are all sort of predominantly urban and developed nations. So it is kind of interesting because this is where we think we can really start to drive this movement towards decarbonization by helping people make that switch over from cars. Now, we also know that 70% of all urban passenger commutes are between 3 miles, below 3 miles, and 50% are below sort of 10 miles. So there is no reason why people need to kind of, sort of traverse this distance using a car, in everyday kind of use. And when we look at this sort of a slice, what we've sort of realized that it's kind of disproportionately impactful, despite the fact that it is a fairly thin slice out of the entire sort of emissions spectrum. One, because it's predictable. It happens twice a day, 5 times a week. It happens at scale, billions of trips every day. And it's relatively easy to make that switch from cycling to cycling, walking, and electrified transit. And that is why it makes it a very high leverage point for decarbonization in that slice, which is the 5 sort of top sort of developed nations with the maximum sort of commute emissions. If we look at now the decarbonizing this particular sector, if you were to kind of look at the cost difference in terms of I mean, we talked a little bit about the time difference, and it takes 16 years for a car to be on the road, which you buy, and only 10% are kind of electrified. But if you just look at the cost, it's just disproportionately off. And of course, we look at this cost, we look at shared mobility as, of course, one key sort of way to drive this forward. But then the e-bike conversion kits and the new e-bikes. So if we can kind of get people to make that switch really easily, affordably, I think we can drive this decarbonization movement a lot, faster, and we can kind of accelerate that. So this is kind of where I come in with the product, because when we look at these two kind of options, which is the new e-bikes versus the e-bike conversion kit, what we notice for the city for 3 to sort of 15-mile commute, a typical e-bike is, it's overpriced, it's overweight, it's a bit of an overkill. So what we essentially designed is a small portable device that you can essentially attach to any regular commuter hybrid shared bicycle, and essentially convert it into an e-bike, which, it kind of looks like this. It's a fairly small device. You don't need any tools to attach it. It comes right out of the box, and you can essentially, put it on your bike and go. This is one of the first versions that we've developed for the US and the European countries. We are also working on a much more affordable version of this that we call Bolt, which is going to be around $100 kind of a price point, kind of taking inspiration to the one laptop per child kind of idea. And this is, I think, what we believe is going to accelerate and help sort of decarbonize this kind of a segment. I am pretty much, sort of done with the presentation. If anybody is not familiar, I can show a quick video on how easy it is to attach it. So
I mean, if it's
maybe
like a 30-second video, it should be
yeah,
fine.
it's a super short video.
Yeah.
So I'll just hold this up over here. I'll stop share, and I'm now in. So this is basically how easy it is. This is a 20-second video, and so that's pretty much it. Thank you.
All right. Thanks so much, Som and Tom. And we'll get into the questions once Tom is done with his presentation.
Great. Let me know when that share pops up.
Yep, we see full screen.
Okay, great. Well, thanks everybody for being here. I'll definitely start by providing just some high-level context and maybe try to put some numbers to some of these kind of qualitative realities that we've been talking about. I think everybody knows that road transportation is a big chunk of global emissions, but if we rank them by end use, it is actually the biggest at about 12%. Now the IPCC has released carbon budgets based on global emissions through 2019, and these basically say that if you want to keep global warming under X degrees Celsius, then you have to keep cumulative emissions after 2019 under Y gigatons. Unfortunately, we've already used up a pretty good chunk of those budgets, but we can take what's left and multiply it by that 12% and come up with carbon budgets for road transportation. I'll come back to that in a little bit. So right now there's 1.5 billion cars in the world. We produce about 85 million a year. We scrap about 50 million. We're at about 15% EV sales in the US if you include plug-in hybrids, about 25% globally. Now, if we take the EIA's projections for EV adoption and fleet growth and project that out to 2050, then you wind up with a much larger fleet, and the number of gas and diesel vehicles has only gone down to about 1.1 billion. So now coming back to those carbon budgets, we've been focused for a long time on staying under 1.5 C. I think we're at the point now where we have to say that's not going to happen. We're going to exceed that. So if we instead focus on 1.7 C, which is about as aggressive today as 1.5 C was back in 2019, we can take this adoption scenario and calculate the emissions that will result and compare it to those carbon budgets. So if we do that, even being very generous, assuming that the grid will decarbonize, at a commensurate rate, we blow right past that 1.5C budget. And then we actually go on to exceed a 2C budget, which is really catastrophic from a climate perspective. So that's the course we're on. But what's interesting is what happens if we really hit the throttle on EV adoption. So even if we transitioned vehicle sales to be 100% electric by 2035, which I don't think anybody thinks we'll actually achieve, we'd still wind up emitting 175% of that 1.7C budget. So this tells us that we need other solutions and that electrifying existing vehicles should be one of them. Now, vehicle conversion, it's been around for a long time, but it's really been held back by two Achilles heels, and those are cost and scalability. So you could take your vehicle today to any one of these conversion shops, and they're probably going to quote you somewhere north of $40,000, potentially a lot more, and it's going to take weeks to months. That's because the design and engineering effort that goes into tailoring the solution for your specific vehicle is very expensive. And because any custom parts that are fabricated are going to use low volume manufacturing processes, making them really expensive. And then, of course, the actual installation process is very labor intensive and very specific to the vehicle. So it really has to be done in-house and incurs a lot of expense. So we're taking a dramatically different approach, one that leverages three pillars. First is that we convert into plug-in hybrid instead of battery electric. This really makes most use of what already exists, including the engine, and allows use of a much smaller battery. So we provide enough range for daily driving, but then we keep the engine available for road trips, towing something, heading out to the wilderness, that sort of thing. The second pillar is that we've developed vehicle agnostic product architectures. This means we can invest in the tooling required to mass produce the components at a dramatically lower price. And then lastly, we have a simple, fast, and consistent installation process. This both keeps labor costs low, but also unlocks the use of third parties. So any mechanic anywhere in the world can install these systems in about a day. From the customer perspective, you get a positive ROI in as little as 2 years. You can generate up to $40,000 in lifetime savings. We've designed it so that the electric motor and vehicle engine can work together as a generator, so you can generate power for job sites or home backup or whatnot. And all this comes with no EV sacrifices, no range anxiety, no issues with towing or heading out to the wilderness. For the nerds in the audience, this is our first product. We call it the Narwhal. This is for pickup trucks, vans, and SUVs that have a solid rear axle. What we basically do is remove the drive shaft, cut a section out of the tubular part, and then bolt our drive unit into the middle of the drive shaft. We then connect that with a reaction torque linkage up to the axle tubes. Inside that drive unit is a stack of axial flux motors, a planetary transmission, and then a multi-mode clutch. We also have a system designed for essentially every other light-duty vehicle, and then we have a platform for applying a range extender to existing electric vehicles as well. Now, from a climate perspective, what does this do for us? Well, if we look at all the barriers to turning over that fleet as quickly as we need to, there are really 5 core challenges. The first is just production costs. We got to make stuff, and that's expensive. The second is that all that production comes with a carbon penalty. Making stuff is a dirty business. Third is if you're going to make extra vehicles, you got to make room for them, and that means prematurely scrapping cars, and that's basically represents wealth destruction, and somebody's got to eat that. Lastly, or fourthly, there's battery production. We might need more than we're predicted to produce, and then lastly is charging infrastructure. You got to be able to charge electric vehicles out in the wild. So 3 of these problems are really addressed by the retrofitting approach, and 2 of them are addressed by the plug-in hybrid architecture, and we basically combine those 2 together. So if we look at what it would actually take to achieve that 1.7C carbon budget that we talked about, using either just accelerated EV production or a blended approach of EVs and retrofits, the difference is pretty stark. So if we're only going to make new EVs, we have to increase total automobile production by about 50%. So the size of the automotive industry has to grow dramatically. That comes at a production cost of like $26 trillion. With a blended approach, we don't need to do that, and the cost of producing the kits is under $4 trillion. EV only is going to require 50% more battery production than what's been predicted to happen. We can get that down to 15%. If we do only EVs, we're going to need 2.5 million extra public chargers we wouldn't otherwise need. With the blended approach, we need none of those. To make room for those extra EVs, we'd have to scrap about $10 trillion worth of otherwise good cars. with retrofits, we don't have to scrap a single extra car. And then lastly, from an embodied carbon standpoint, to produce all those EVs would incur about a 15 gigaton penalty, and each extra car you wouldn't have otherwise produced takes about 8 years of driving to break even. Producing retrofit kits is going to cost you about 1 gigaton of carbon, and each individual unit is going to break even from that carbon penalty in about 6 months. So I'll stop there, and I really look forward to the questions and the conversation. Thanks.
All right. Thanks, Tom. So yeah, so let's get into the the discussion. Ali, I'll probably start with you. So if I'm a truck operator, and you mentioned this, that it's all about ROI and return, or on investment, is this going to save me money? So if I have X amount of money with me, should I get an EV truck, or should I get an electric trailer? What is the ROI? I understand that the battery is 288 kilowatt hours. It's like 1/3 typically, or half what you'll find on an e-truck, so the cost should be lower. But yeah, so do y'all have any sort of maths, because people must be coming at you with this question, because states have policies for EV trucks, but there's probably, I don't know if there's something for trailers. How do you justify this?
We could fill the rest of this meeting with answering that question, because there's a lot of regulatory aspects. Let's just take the baseline where one of the challenges we have today is that trailers have not been thought of as a decarbonization tool, and as a result, the carbon credits, the allowances, those things don't quite exist yet. They will. They are in the process of happening, but they will. All of that aside, if I'm a fleet owner, the reason that I would rather electrify my trailers than my tractors is because I can electrify my trailers and continue to rely on the very critical primary movers that I have in my fleet that I know will get my load to their destination every single day. The beautiful thing about our trailer is that we fail operationally. What that means is that even in the worst case scenario where we have a total system failure, we have clutch releases where we then just freewheel the axle, and then you're just pulling a trailer. And I counted about 6 questions, and I'll try to answer some of those questions through this process. Our system weighs about 6,500 pounds. Only about 20% of the loads on the road, or 25%, are massed out, meaning they run out of mass allowance. So if you think about all the boxes from Amazon that we get and all of this stuff full of air. So yeah, ultimately, the reason that I would electrify the trailer is because, number one, cost, I can electrify 3 trailers for the cost of 1 tractor. Number 2, charging infrastructure. I can charge at the loading dock, and because my battery is small, I can actually use existing shore power to charge at that loading dock. Number 3, if I run out of range, if I have to do some, double my route one day or something like that, that trailer is going to continue to be there to help reclaim regen energy and still get 10 to 15% better fuel economy, even when it runs out of its usable range of 300 miles. A tractor doesn't do that. You're stuck.
Yeah, no, that makes sense. Thanks for that. And on this topic of not having policy for e-trailers yet, so Tom, I don't think there's policy for an e-bike retrofit yet, and Tom's the same thing for ICE hybrids. So I'm guessing, is that a barrier for your product adoption? And so we can maybe start with you. How are you all approaching this, right?
I think there are 2 pathways for our sort of deployment. One is direct to consumer, and as we go into kind of bigger retail, I think one of the key ones are certifications around safety. So UL and all of that is currently it's something that we are doing, and we are going to be ready with that. On the other hand, someone asked a question about rebates, that the government currently sort of gives out rebates. I think that also becomes really interesting for us, because typically the rebates are designed in such a way that someone has to still spend another $500, $600 out of their pocket to get an e-bike with the rebate. But with CLIP, it can almost be almost free in that sense. So I think we are kind of looking at certain sort of geographies, like California has rebates that we are eligible for. But then there are other places the language is such that e-bike conversion kits typically are not ready for rebates. So we are kind of working with them to kind of include that. But once that comes in, I think it will just be very affordable for everybody.
All right, thanks for that, Tom. What about the vehicle side of things?
Yeah, so in our case, because we're operating as an aftermarket kit, that we don't are not subject to the same rigor as if you're making a brand new car from scratch. The automotive aftermarket is particularly in the US a lot more loosely regulated. That being said, we actually welcome regulations. We at the current state we really have to define what's acceptable and safe and all that. And if regulations were in place, then we could just meet the regulations. Australia has them for retrofit, so I think it is coming, and we actually welcome that. On the incentive side, we're very excited about the prospect of qualifying for EV tax credits. Maybe not in the next 3.5 years, but hopefully after that. And for example, if we currently qualified for the federal EV tax credit, we'd be essentially giving our systems away for free, just because they're so cost effective.
Okay, so I mean that's the approximate ballpark that you are targeting. Like the current EV tax credit is where you're looking to land.
It's in that ballpark, yeah.
Okay, all right. So I'll probably come back to you, and this is a slightly tangential question. So we are combating car bloat in the US. Pickup trucks, SUVs have gotten like way heavier, way taller, and this is adding to a lot of pedestrian crashes. Why are most e-bikes also bloated? They have these fat tires, incredibly heavy, and you just cannot pedal them without electric power. Like suppose you run out of batteries, they are so heavy, like you barely move at 5 miles an hour. So why are we looking at this trend? And you highlighted this, right? You showed the photo of an e-bike, with
Right,
those massive
right,
tires. So
right.
why can't we? I mean, it's good for you in a way. You will sell more clips, but why is this trend of bike bloat happening? E-bike bloat.
I think it's like a weird psychological sort of trend that's kind of been co-opted from the car industry in that sense, and also this phantom sort of anxiety for range. Because typically, when you look at like a bicycling usage, you're not bicycling more than 10 to 12, maximum 18 miles every day. So you don't really need a gigantic battery to power you for that use case. So what happens is to kind of calm that anxiety, you put in a giant battery and then you put in a big motor, and then you have to kind of have a much bigger frame to hold all of that in. So it's kind of like this weird feedback loop which ends up in that kind of a place. Uh, but on the other hand, if you really think about it, and the other thing I want to mention is also the user experience of these e-bikes. So when you're riding an e-bike, you're essentially kind of building like a glorified e-scooter. You're no longer bicycling anymore. You're essentially kind of pulling a throttle and just kind of coasting. So that's not quite what an e-bike should be. An e-bike is essentially a hybrid where a person, a human kind of pedals and say 50 or 60% of the effort is taken away by the motor. And that's kind of where we are kind of finding the sweet spot, because if we kind of look at it from this point of view, you have a much smaller footprint, a much smaller weight, and we believe that is the right sort of way to look at it.
Yeah, no, that makes total sense. Ali, next one for you. So you showed in your video the snow testing, and I think there was a brake test with a Jeep or some other vehicle.
Yeah.
I think this is a big win, like safety.
Yeah.
Shorter braking distances of Class 8, trucks and trailers, and not having the rear come out.
Yeah,
turns. I think that should be a selling point also, right?
It is. The thing is that. Go ahead. Sorry, I'll let you finish.
Do you have quantifications on how much the braking distance actually reduces compared to?
Yeah, actually, on that snow and ice video, there was a little clip that I cut out. I should have kept it in there. A trailer and tractor system. So that was done with regular pavement tires on a ice surface. That all those videos that you saw, and we were matching the performance of that family SUV. It was a Dodge Durango in that case. And when we quantified all of that, we did multiple tests. One of the tests was all of the ABS off on the trailer, but the ABS on. The ABS always stayed on the tractor, but we turned the trailer ABS off. We turned the trailer ABS on. We realized about let's say half a car length or maybe 1 car length increasing braking performance with the ABS off and on the trailer. And you have to remember, this is old school ABS. It's got modern sensing, but it's still air over hydraulic ABS. So the actuation is very, very high latency. Our system our trailer braked the system 15 meters shorter than before. That's like 3 car lengths. And so we are about 3 to 4x increase in braking performance over the baseline ABS. And so, yes, you're right. This is a big game changer, along with the jackknifing control and all of that stuff that we can do. The challenge for us as a startup is how do we quantify this? Because the fleets are like, that's cool. How does it save me money?
I
You
mean,
can tell
insurance
them,
and, crash costs.
sure, but they want to see the numbers, right? And they want to see exactly what that means today. And so I can absolutely point and say, look, even NHTSA and DOT are saying that we should start thinking about mandating this technology, but everybody's like, I don't care. If it doesn't save me money or make me money, I can't use it right now. And so ultimately, we're trying to quantify all of these savings that are the safety behaviors that we have with insurance institutes, with fleets that are self-insured, and with regulators, so that we can go back to the fleets and say, listen, this is how much money you're going to save. And we'll go with the insurance agencies to say that this is how much we're going to cut off of your bill if you use the range energy system.
Yeah, that makes sense. Yeah. Tom, next one for you. So, I mean, the variety of cars on the road is mind-boggling, right? Different chassis, drivetrain layouts, electronics. Even the same Honda Civic sold in 2 model years will have different ECUs. One made by Bosch, one made by Denso or something. Unlike, say, trailers or regular bicycles, which are more standardized. So, how do you approach this problem of just the sheer variety of vehicles on the road? And maintain installation quality if you franchise this? The guy might be used for 1 model year, but next day some other model year turns up and it's a different thing. So, would that impact, the 1 day that you mentioned of retrofit time? I'm just curious.
Absolutely. And that, I mean, that really is the challenge of how to make this work, was developing a product architecture that accommodates all of that variability. And so the basic strategies there are to leverage common interfaces and build kind of geometric adaptability into the architecture. So, with the Narwhal, our launch product, every vehicle in that category has a drive shaft that runs from the front of the vehicle to the back. Every drive shaft has a section that's just a hollow metal tube. Okay, that's an interface point we can use. So you can remove that drive shaft, cut a section out, weld on 2 flanges, and then our unit bolts into the middle of it. And then every vehicle like that has a solid axle in the back. That's what we attach our reaction torque linkage to. So that common interface point is one thing, one aspect we've used, including things like you can put a trailer hitch on every vehicle. That's another kind of hard mounting point that you can use for attaching things.
Sorry, could I just jump in there? So, I've reinstalled the drive shaft, and you have to note which ends go into which ends, because it's balanced from the factory, and you have to keep the same balance to prevent the NVH from coming in. So how, when you install this, make the modifications, you rebalance it? What's the procedure?
Yeah, you'll do a rebalance. So, fortunately, driveline shops are ubiquitous. Obviously they serve the heavy truck industry, they serve the aftermarket industry. So if a particular mechanic doesn't have that ability in their own shop, then they would take it to their local driveline shop for a balancing. Yeah. And then the other strategy that makes this possible is minimal integration. So we keep our system almost completely separate from that of the vehicle. We have a separate throttle. All we really have to do is interface with the 12-volt system to make sure that stays charged up. If the vehicle has hydraulic power steering, we install an electric pump in parallel with that. But really, our system is a self-contained electric propulsion system that, for all intents and purposes, bolts on with very little integration to the vehicle, and that helps us be agnostic and then get that mass production.
Okay. So last question from me before I just hand it over to John. So, you started off your slide, talking about 3 to 5 15-mile commute, and that 50% of them are below 10 miles, and I think 70% are below 3 miles. So in my mind, 3 miles being replaced by a bike, it's feasible, doable. 10 miles, I think, is sort of pushing, what people are, the limits of people. And if you then stick to the 0 to 3 miles, the greenhouse gas emissions are not, that huge, obviously, because it's a much smaller commute. So, of course, you save congestion, particulate matter, and all the other, good externalities. But do you really think, you'll see a lot of success in the 10 to 15 miles category, or will you just, sub 5 miles mostly?
I think sub 10 miles is absolutely possible in places like New York, for example. I mean, there are many people who kind of sort of travel from Queens to Manhattan.
This is one way, right? This is one way.
One way, yes.
One way, yeah.
So they take, the subway. A lot of them actually use a bike to go from, say, Queens to Manhattan. So it's not crazy when you start actually sort of having an electrified boost to your bicycling. I mean, a typical, say, a commute time in a bus. So, for example, like my commute is about 4.5 miles. If I take the bus, it takes me about 45 minutes to get to work, and that is, with all the stops and all of that stuff. If I, take a car, it's kind of something similar. It's about, with all the traffic. But when I take a bicycle, it takes about 12 minutes. So with CLIP, right? So, and that is kind of the delta that, more and more people, when they understand what they gain from taking up a bicycle for that commute, which they are kind of sitting around in a subway or in a car stuck in traffic,
They'll be more
that
willing.
becomes a lot more obvious. Exactly.
Okay. All right. Okay. John, over to you for the audience questions. Thank you.
Okay, super. As always, very active chat. I'm going to start with some of the questions that are applicable for all three of you. And there was a lot of discussion in the chat about cost and also to a lesser degree about regulation and how that impacts cost. So, I mean, some of you touched on this, but just for clarity, if you had to sell your product today, can you share sort of what is the price point? So, Ali, what and actually ground us, what's the cost of a tractor trailer combination typically today in US dollars?
Yeah, the numbers are all over the place. So they rarely do people buy a tractor and a trailer together. Almost, I would say never. Typically, you buy your trailers from one supplier and one dealer network, and the tractors from the similar dealer network and a different supplier. Tractors are typically a day cab could be 150,000 all the way up to a sleeper, let's say 180 to 200,000. The electric version of that is between 350 and 500,000. So a huge price delta. A trailer, typically baseline for a dry van trailer or refrigerated, let's do refrigerated trailers, typically are around 60 to $80,000. The refrigeration unit is another 40, let's say 40, 30, $40,000 in some cases, depending on you want to add lift gates and auxiliary power units and all of that stuff. Our system, we're not really publicly releasing the pricing on our system yet, unless you're a fleet that's signed up, you'll get the pricing, but it is meant to match the current ROI patterns of a lot of these fleets. And so we are not coming in at 3x or 5x the typical price that you would see. Because we have a nominally 300 kilowatt hour battery pack, we can be very price conscious and focus on ROI. So our focus really is, how do we get these fleets to an ROI of 3 years or 4 years as quickly as possible?
Okay, excellent. Sam, for the CLIP, can I buy one right now?
Absolutely. We have shipped close to 1,000 clips right now in the US. We've sold about 2,500. You can buy it on our website, CLIP.bike. And in terms of the cost, so a decent e-bike will cost you about 1,500, 1,200, 1,500 and above. They'll go up to 4,000, 5,000. CLIP comes in at $499 for the commuter option, which is perfect for the 6 to 8 mile commute. And then it comes with an Explorer option, which is good for a 12 to 18 mile commute. So with that and with the rebates in some states, it can be as little as $100 or even less.
Super. Okay, and you just snap it off and take it with you, and don't worry about your e-bike getting stolen.
Exactly. Great. It's basically that thing. It's super simple. Yeah.
Fabulous. Tom.
Yeah, so you can think about our systems being sold in sort of small, medium, and large. And so on the small end of the spectrum, something like a regular sedan, you'd be in the sort of $6,000 ballpark. If you go up to something like a heavy-duty pickup truck, you'd be around $9,000. And then there'll be various optional accessories that you may or may not want or need for your vehicle. And then we also intend to offer 2 battery pack options. So one would be on the sort of 35-mile range for a given vehicle, and then the other would be sort of 45, 55 miles.
Do you get questions, Tom, about kind of what's the payback period? And of course, then you ask, well, how much do you drive per year and so forth. But is that the way to think about this? Like, okay, if I invest those $10,000, I'll make that money back. And by the way, help the planet in
Oh,
X
absolutely. Yeah.
amount of time.
We our first client to sign up for a pilot program was a school district in British Columbia. And when they have a fleet of pickup trucks and vans, mostly used by their tradespeople. And when we did the analysis on how their fleets are actually used, given their usage data and their mileage and everything, we showed that it would pay for itself if they did their entire fleet. So even some of the vehicles, it wouldn't really make sense. If they did their entire fleet, they'd break even in about 2 years. And then over the life of that conversion, they'd save over $1 million for the school district.
Okay. Jessica Farmer asked, which of these technologies are intended for sales overseas, particularly in emerging markets over the next few years? And Sam, you responded that you're moving into EU, India, and Africa next year. From Ali and Tom, is this a US product for now, but planning to go global? Where do you stand? Ali?
My mission here is to electrify every trailer in the world. So we're starting in North America, in United States. We will move up to Canada and down to Mexico. And then from there, we start looking overseas, Middle East, Asia, and Europe.
Yeah, very, very similar. So we are very excited to get into overseas market, particularly into low income countries. If you've ever driven in places in Africa, in India, the vehicles are much older, much dirtier. In fact, the US and the EU, we basically send our old dirty cars to those places where they might live another 10, 15 years because labor is cheap and parts are cheap for those kinds of cars. And so in some ways, I'm not sure there's another option for electrifying those parts of the world other than a cost-effective retrofit approach. And the problem is really not that EVs are expensive, it's that new cars are expensive. Very few people around the world will ever purchase a new car in their lifespan. And a typical car in the US at least has a lifespan of about 21 years. So yeah, we're very excited for the opportunities in those markets.
Excellent. Okay, so Heather Richardson asked, are these products recyclable at end of life? And I think this is actually an interesting question because all three of these use cases are deploying, battery to some extent. So I'd ask you just to reflect on that, how you think about end of life, and also if you have comments more broadly about, the electrification trend and what do we do about all of these very large batteries and how do we prevent them from ending up in landfills? So, Ali, I'll start with you.
This is like one of those biggest, it is a huge deal for me. Not only because I'm a huge fan of what folks like JB Straubel are doing with Redwood Materials and really closing the loop on everything that we're building today, but JB was my boss for 5 years at Tesla. And so we really thought all the way from the beginning to the end of all of this. And every single system and subcomponent of our system is meant to last at least 10 years. And when it gets to end of life, we have strategies that are being formulated right now on recycling all the way back down as far as we can go with all the different components and materials. So that end of life is a huge deal for us.
Excellent. Sam?
Yes, I think, if we just look at the battery size and the range kind of proportionality, I mean, CLIP has the most optimized battery size. The commuter is a, sub 100, watt hour battery, which, gets the job done in the 6 to 8 mile commute. So from that point of view, it is, the smallest battery. And then, a typical life cycle at the end of which we will essentially, refurbish the units. We are kind of working on plans to kind of upcycle some of these unused, the end of life cycle batteries. And then from the circularity point of view, we are this thing essentially makes sure that the billion or so bicycles that already exist in the planet, they can be reused and kind of brought back into work instead of having to build a whole new set of e-bikes. So from that point of view, I think from the manufacturing standpoint as well, this is, sort of magnitudes kind of lower in terms of its carbon consumption.
Okay, and then just Tom, anything to add?
Yeah, I mean, very, very similar for us. So, we're keeping a vehicle out of a scrapyard. That's a huge, huge savings in carbon emissions and pollution. Because we're plug-in hybrid, we have the same sort of small battery advantage that Sam has. You get about 70-80% of the benefit with 20% of the battery, so it's a huge resource efficiency. And then thinking ahead to end of life, we're focusing on lithium iron phosphate battery technologies, which are much easier to recycle. They have fewer rare earth minerals and whatnot in them.
Okay, super. I'm going to try to hit a couple specific questions. And Tom, I'm going to start with you. So Rajan Chadhauri asked, is this vehicle allowed by vehicle norms? I think the question here is about certification, regulatory compliance, just anything to say on that journey of yours.
Yeah, so one of the reasons why we're excited about those overseas markets, but we're starting in the U.S. and part of that is because the aftermarket in the U.S. is very loosely regulated. There are some things we'll have to do and some hoops we'll have to jump through. We'll have to get a certification from California saying that we're not adversely affecting emissions control, which is one of the reasons why we're not doing a blended hybrid approach. You're either operating on the electric motor or on the engine, so that there's no confusion about whether we're affecting vehicle emissions at all. And then once we move overseas, particularly into Europe, where the aftermarket is much more constrained, we'll have to meet those requirements. And then we hopefully at that point will be able to encourage enabling regulations that will make a path forward for us and other companies that want to enter this space.
Super. Okay. Andy Burnett asked, will CLIP work on a bike with front suspension? I'm putting this one out there because it sounds like you might have a potential customer.
So we currently CLIP itself, the main product does not work with suspensions, but we are developing Bolt for India, which will be which is being designed for the front suspension. So it will be, so we will have Bolt very soon, which will be for the front suspension. We also have something called Blip, which is kind of a really fun little thing for the folding bikes, for the Bromptons. So we are excited about that one. It's really fun to ride, like a go-kart.
Super. Okay, you're diversifying your portfolio of products. That's great. And then finally, Ali, there was a question early on about the weight penalty of your system. You said it weighs about 6,500 pounds. That led to a comment from Marty Schlenker, which was interesting. He said only 20% of the dry van loads are massed out. And then he was sort of asking about any stats for flatbed, dry bulk, liquid bulk. This really gets into the core of the trucking industry, but just any thoughts on, is that 6,500 pound penalty really significant in terms of implications for the industry?
For most fleets, it's not an impact at all. Even on the fleets that do typically mass out, like food and beverage distribution, we're finding that because of how we're sensing, we're actually more efficient the heavier the load, because we can reclaim more kinetic energy in regen. And so a lot of the fleets are finding that their fuel economy is going up dramatically with our system, and they're willing to put 1 or 2 pallets aside in the route and catch those pallets up, after the 10th truck or something like that, to make these operational efficiencies work. But that being said, we have not seen one fleet take 1 pallet out of their trailer yet to accommodate our system. They've all been able to make it work because the system efficiency is just so good.
Excellent.
Good. It's a while to now. Sorry to cut into the just brilliant conversation. Thank you, Ali, Tom, and Sam for joining us. Brilliant. It's really a different perspective looking at this. The only thing I would add is we can study what happens in the housing and the building industry. I mean, in transportation, we have a 10-year lifespan, 20-year lifespan. In housing, you're talking about 100-year lifespan. So that industry recognize you have to retrofit early on, right? I'm not sure they are all successful, but both success and failure we can learn from the personal choice. corporations response, government intervention, very systematically look at this. That would be a beneficial thing to look at how the two sectors play out at this. This is the end of the Spring 2025 Mobility Forum. I would say that it's quite a run over the 4 or 5 years here, right? I do want to thank my partner, John and Buwang, for joining me, make things happen. Thank all the speakers today, Ali, Sam, and Tom, and all the over almost 200 speakers talking to us, sharing the experience. And also thank the audience joining us. I want to connect to something that I want to share today, that is the higher education as a community or research enterprise as a whole in the United States is under attack, including what happened to Harvard yesterday. Here, I think many of the audience here are beneficiary of the system, and the whole society is benefiting from the system. I just call for everybody's support to do whatever in your discretion, your capacity to help support this system. Mobility Initiative is doing our small part through this Mobility Forum, because I find underpinning all this issue is a disconnection between academia and the general public, right? The more advanced the technology we talk about, quantum mechanics, gene editing, large language model, the more distant and foreign people feel, the higher the degree of indifference here, right? So through the forum, we try to share some of the best innovation from academia and research and industry, share with the broader public, engage the public and inform them. I hope that many of us can continue to do that and bringing this the crown jewel of U.S. society back to its stand. In the summer, we just started designing the fall 2025 forum. We'll really welcome your suggestion, recommendation, what topics should cover, what speakers we can invite. So please let us know your ideas, and we'll absorb them into our design into the fall. During the summer, we may introduce a few ad hoc sessions. We'll announce it over the email. Thank you again, and have a great weekend and a good summer. See you in the fall.